this video I will show you how to do like a cluster analysis and inspect the clusters. So if we read it in, we see here that there's indeed like many variables. So what we're going to focus on is the price and the sales. So there's these variables. So here we see all the variables. We're going to create an object that actually has the variables names that we're interested in. So indeed there's going to be week 1, week 6, week 12, week 8 and 24 for both sales and price. I'm going to add processor, the OS variable that I've created before, the RAM and the screen size. So each row is a tablet that has been sold. So for each tablet they have the title, they have the sales and the price, the model type, they have the operating system, the type of processor, the battery life, screen size, screen resolution, the weight, etc. There's many missings in the dataset. It's kind of like a messy dataset. But overall, you know, there's lots of information to be found. So as you can see here, there's also some missings. And here's some missings. 163 tablets, and we shall see with complete cases that's very less variables. Take only the variables that we're interested in. So remember, this is the DF. The square brackets indicate that I want to take something from the DF. You know, precise, to be precise, I would have to place a comma here to indicate that I want to have like all rows and only the columns with the names indicating in the vars. Yeah, so let me do that. So now also vars is in my environment. And if I take the data frame with the vars, I get only those columns that I indicated before. And so if I do it like this, it will do the same thing. Okay, now what I would like to do is to standardize variables, because that's something that's always very useful for clustering. So if I do this, then I use the apply function on the columns and I say scale. Now we can see that, you know, for instance with processor this will not work very well. So I think what would be nice for this point, we just remove these variables for now. Right, I'm going to save them for later. So I'm going to create these variables, which are only the variables that are actually used for the analysis. And then I'm gonna create a new set of names that is gonna be the standardized of the scaled variables. Just gonna create new names so I do not overwrite my variables later on when I create these and I want to add them to the data frame. Yeah, so now all of the variable names has an S in front. I say from all the variables, so now these are only numeric. Right, so you see it's only numbers. We say that we're gonna scale them. So if I do this, then you see that now these data frames, they have scaled variables running from, well, I can show you the summary. It all has like a mean of 0 and it runs from minus something to plus something depending on the scale. Yeah. Okay. Now we want to use this later on, so we're going to save these results in the data frame with these new names. So we're going to create columns, which are not there yet, right? Because they cannot find. I haven't run this one. So if I now run it, it says like no undefined columns. Yeah. So if we're going to take what comes out of this function and move it into these columns, then actually it will be able to find it. You see? So now there is like all these columns with the standardized variables. Yeah, so now we have only a few observations. So let me show you how many actually. So now 193 observations are left, right, from the 2100 63 that we had, now it's like only 193. Okay, if we do the k-means on this, you get a solution. Yeah, you see here the cluster means. This is clusters for each case in my data. So you see there's many ones, so most of it is actually clustered in the first cluster. And then these are within some some squares. And then there's some different things that we can also get from these frequencies. We know that like the majority is clustered in the second cluster and the first in the first cluster. Now you see that here when we ran it before, it was actually the other way around. Most of them were clustered in the first cluster. Yeah, so now I know that with 9099 I will cluster most of it in the second cluster. If I use 123, I will cluster most of it in the first cluster. This seed, if it runs exactly on the line before the k-means, it means that you'll always be able to reproduce your solution. Now, with this km cluster, I can actually start to look at the results. Yes. Now the problem is that this still is like the same length of everything, and then the km cluster only is for the non-observed. So how are we going to add those two together? So that's always very tricky. So let's make an index of the row names of NA-ONIT, DF, vars. So this index indicates all, which means now we have the index for which we have calculated these k-means cluster, right? So the index shows like 193 observations. So if we then say df index, we take all the observations. So let me first create a new column that is called cluster in the old data frame with NAs. And then we say that for those values on cluster which relate to this index, we add the km cluster. Yes. So now what we can do, we see that there are indeed like these clusters. Now we actually have the opportunity to say here, let's just only compare the screen size for those. So 193. So if we then apply it, so now we know what the mean value is of screen size per cluster. So you see that one cluster has a much higher screen size. Now then we could also run an AOV, an ANOVA, to see whether it's significant. And we see indeed that it's highly significant.